Good day, everyone. Thank you very much for joining us for today's MicroFocus webinar on COBOL, containers, and cloud, our introduction to our latest release of Visual COBOL version 4.0. So thank you very much for taking the time to join us today. We've got a lot of great content to cover, and we're eager to get started. Just one quick reminder, as always during our webinars, we want to be able to answer any questions that you have. So we will have a dedicated Q&A portion at the end. So feel free at any time during the course of the presentation to enter any questions you have in your question panel there in your GoToWebinar interface, and we can have those queued up and ready to go when we reach the end of the presentation. So like I said, we've got a lot of great content. Let's go ahead and get started, and I'm going to turn it over to our first presenter, Ed Airy.
Brandon, thank you very much. Hello, everyone. Good morning, good afternoon. Welcome again to this MicroFocus COBOL webinar and launch event for Visual COBOL 4.0. My name is Ed Airy, Product Marketing Director for our COBOL solutions here at MicroFocus. This is a very exciting day for us here with the COBOL team, the launch event of our latest solution for COBOL modernization and transformation, Visual COBOL 4.0. I'm joined today with some very special guests. You have an opportunity to hear from each of our subject matter experts momentarily. Back with us today is Scott Nielsen, our Director of COBOL Solutions here at MicroFocus. You have an opportunity to hear from Scott momentarily. He'll introduce some of the new features and new capabilities in 4.0. Also joining us here today, Blair and Jen. Both Blair and Jen will be leading our product demonstrations, so you'll get an opportunity to see firsthand some of the new capabilities in this latest release. Before we jump into today's material, though, I'd like to just start with a quick reminder of why this release matters, and particularly why some of the new features that you'll see come into play and are significant for us in the COBOL community. We know that many organizations today, many of us in the community are undergoing transformation projects within our organization. Transformation projects to enable IT to be more responsive to business change, but also more responsible to the needs of the business as it goes forward. The pace has certainly changed. The expectations from our customers in the marketplace have also changed, requiring us to think differently about our core business systems. So what we need is a new approach in terms of how to leverage what has made us successful thus far, our core applications, and enable us to bridge to next generation technology, to be able to take our systems forward into the future. This is the solution that we've adopted here with our capabilities, and the solution, of course, that you'll hear more of today with the release of 4.0. It's a holistic view around application transformation and modernization. Looking at the application itself, the process in terms of how we build software, and then of course infrastructure, the platforms on which those systems run. Our view is quite unique, our approach is quite unique in that we enable our customers, developers today to be able to extend the application, whether it be at the code level or through the user experience, to new environments, new APIs, new architectures. We enable developers to transform the way in which they deliver software. So whether that be through waterfall practices or through Agile and DevOps, or perhaps it's a hybrid model, by effectively enabling them to transform the software development process. And we give you choice and flexibility, and in many ways independence in terms of how and where you deploy those applications. If that's on-prem solutions, if that's the cloud, if that's a hybrid model, whatever the right mix is for you, we give you that choice. So it's important to recognize that this is a view that you can define. This is modernization on your terms. It puts you in the driver's seat to be able to take your business applications forward into the future. But what we're here to do today is to talk about how these capabilities map to the latest version of Visual COBOL and how you can take advantage of some of those new features and again, take your business applications forward into the future. So it gives me a great pleasure here to introduce our next speaker. Again, back with us is Scott Nielsen. Scott, I'll turn things over to you.
Excellent. Thanks very much, Ed, and a very warm welcome to you all once again. Sincerely, thanks for taking the time out of your day to join us here for this launch webinar. It gives me great pleasure. I'm delighted to go through the highlights of this release with you today. Now, there are somewhere in the region of around 150,000 hours worth of engineering investment that has gone into both this release of Visual COBOL combined with the enterprise developer release that's happening in parallel at this time. So it's a tremendous commitment by Micro Focus and our Micro Focus engineering teams, but one that we're very proud to stand behind. Because not only does this represent really the next major installment, the next major milestone of the Visual COBOL product line, it's also the next major milestone in terms of application modernization that we can offer for our customers. And customers that we know who have been investing in their applications for, well, the measurement is decades, much more accurately than years, mere years, in fact. A tremendous investment that they've made in those business systems that we want to help ensure that have a very long, bright future ahead of them. Now, Ed has already outlined, our view and our approach to modernization in these three major themes. And in every release of Visual COBOL, what we set out to do is really to try and push on the boundaries and the frontiers of each one of these areas of modernization. And so, for example, that's about giving you access to the very, in my opinion, the best development tool experience available to COBOL developers, giving you access to modern IDEs like Visual Studio and Eclipse, access to advanced code analysis tooling, to help you work with large, complex COBOL applications, or indeed to take advantage of agile tools so that your teams can participate in modern development environments. It's also about giving you access and flexibility in how and where you deploy your applications. And while predominantly that's about the operating system you deploy to, the actual IT landscape is much broader than that and incorporates things like relational databases. In fact, open source databases are becoming increasingly popular, middleware, and a huge variety of other third-party tools and technologies you need your application to work with, and importantly, to behave consistently no matter where and how you deploy. And last but by no means least, and I think where things can start to get really exciting, because often we're dealing with applications that are decades old and suddenly using them for completely brand new use cases for the IT department. And whatever that use case might be, one of the ways that you might enable it and deliver it could be to put an API into those COBOL applications that's accessible through a RESTful web service is just one example of how you can modernize your application that we can help you with. If you want to find out more about all of those areas and what we've done in this release, and indeed others, past releases of Visual COBOL, what you can do is take a quick look at our online documentation, microfocus.com, look at the What's New section, and you'll find out everything that we've done in this particular release of Visual COBOL. Now, I'm not going to go through the highlights of those any more than I have done today, because what I want to do is really turn our attention and focus on the rest of this session on the main headline for today's launch, which, as you already know, is around containerization, and more specifically around Docker containers. Now, we're going to lead up, in fact, to a demonstration of this in a very short while. Jen's going to take you through that, but beforehand I want to give you a little bit of context about what the problem is that we're trying to solve here, and indeed why that actually matters to us at all in the world of COBOL systems. But of course, not least of which is why it's important when we look at these areas of modernization. Docker actually has a role to play across all of them. So it's important to us, at least, in that regard alone. But let's actually start off by taking a look at the problem that containers are trying to solve for us. And it's put here very neatly and succinctly, which I like. It's really trying to set out to solve an age-old problem that's afflicted development teams and thwarted developers since the dawn of software development. That's about getting software to run reliably when you put it on someone else's machine. So a very simply put objective, but really a grand vision that they try, and a grand problem that they've tried to set out to solve. Now, let's be clear here. Containers aren't trying to address every possible bug that might exist in your application, but they are trying to address an often very problematic situation you have when it comes to deployment. So let's take a look at that in a little bit more detail. I'm trying to depict that scenario here very simply in PowerPoint form, where we have been developing an application in our own lab, on our own clean room environment. We've gone through a great deal of diligence and conducted various and many forms of testing and repeated rounds of testing of the application, because we're determined that it works. And when we're ready and we know that it's working properly, we take the time, we hand that over to our customer. And even though it's the same code that we've tested and we know it's working, unfortunately, things don't often go to plan when we actually deliver it to the customer when they install it. And the kind of things that can go wrong are that the binaries or the libraries, the shared libraries that the application needs, its dependencies, first of all, even be present on the target machine you want to deploy to. And even if they are present, the version that's there may not actually be the one that you've tested your application with. And that can lead and give rise to all sorts of very difficult, challenging things, problems to try and diagnose in your application. Take a lot of time to try and get to the bottom of those sorts of issues. And even if things are working on day one, who's to say that we're working on day two if someone comes along and starts to change the machine in some way and change other applications which are using shared dependencies? That can cause problems for you too. Now, of course, it's not this simple by any means. It's not one or two shared libraries. It's dozens and other tools that you need for your application to function. And it's never just straight into the hands of the customer, is it either? There's many other machines that the software gets installed on before it gets to a customer. And it's never just one customer, of course, either. It's tens of customers or hundreds of customers or thousands of installs where your application can go through. And so the potential for this kind of failure to occur is very high. And the answer, as try as we might, and as much diligence as we might put into this as development teams, the answer is simply not to do more testing. We can't possibly cover all of these different scenarios. What we need is a much more effective way of dealing with this kind of challenge. And the way containers go about this, and to bring this back to the context of COBOL today and a bit closer to home, is that if we built our COBOL application, rather than just shipping that to our customer and hoping our customer has the Micro Focus COBOL runtime installed, and indeed the right version of the Micro Focus COBOL runtime, and indeed all other libraries that you need for your application, let's package all of what the application needs into an image, and an image that we can ship to our customer, and that can run inside a container on their machine, isolated from any other processes that are running and their shared dependencies. Essentially, we bring everything along that we need. And the technology is so flexible that if we want to run another version of our application, we can do that with different versions of those libraries, and are completely unaffected. They can run quite harmoniously on the same system, and indeed as can other applications also running in containers. So this really kind of starts to get us to a point of thinking that, in fact, that we can start not to care about the deployment environment, whether it's hospitable to our needs or not, because we're going to bring everything along in our application that we actually need in order for it to function correctly. And if we follow that through just one step, we're just going to move on to a demonstration very shortly, but if we follow this through and we look at today's IT landscape, which, although there has, despite a huge amount of consolidation of IT systems over the last, couple of decades, there still is a very IT landscape that we have to deal with, and which we just simply call hybrid IT today, because it's not an either-or approach that we can take to this landscape. It's not mainframe or distributed. It's not Windows or Linux. It's not public or private cloud. For some of our customers, in fact, it is all of the above. It is mainframe and distributed. It is Windows and Linux. It's public and private. And that adds a lot of stress and challenges for the IT department to have skills around all of those platforms, to have resources and infrastructure to support all of that. But if we consider the long-term position that we have been in and some of the key attributes around COBOL itself and why it's still here today, one of its most important traits and benefits, which extends into your code as well, is portability. And that's one of the things that our customers have taken great advantage of over the years. In fact, are able to address this diverse IT estate as they've been doing for many decades now. What containers do is really strengthen that argument for of existing business COBOL business applications right across the IT estate that you have to manage. Okay, so why don't we actually take a look at the technology now? We'll just in a second ask Jen to take the stage and do a short demonstration for us. But if I should explain also that the demonstration we're going to do, it's a container, it's Docker, it's not going to be that glamorous, especially because we're just doing a little hello world COBOL application inside of a Docker container, but deliberately simple so that you can see the concepts, you can start to see what's involved and hopefully start to apply these to some of the challenges that you face today with your own application. And hopefully this kind of stimulates more questions in your mind, which we can get to later on in today's webinar. But for now, let me pause, hand things over to Jen to take the stage and introduce himself and take you through a quick demo. So Jen, over to you.
Thank you, Scott. Hi, my name's Jen Namlam. I am a software developer in the Micro Focus Visual Studio team. I joined through the graduate scheme approximately 4 years ago now, and I've worked in a number of different areas in the IDE, such as IntelliSense for COBOL and other editor-related features. Today, I would like to demonstrate how you can go about deploying a very simple application in COBOL and have it run inside Docker. So what I'll show is a simple Hello World application, put it inside Docker, show you how you can run it, and then a bit later, I would like to demo how you can then debug that COBOL code that is running inside the container. When you want to deploy to Docker, the first thing you need to do is create something called a Docker image. A Docker image can be thought of as a template of your application that includes its dependencies and any runtime environment. Micro Focus provides a number of Docker images that you can use as a base. If we look here in my terminal window, you can see that we have some Micro Focus images. We have images that contain the COBOL runtime environment, and we also have some that contain the COBOL build tools. This means that if you wish to actually compile and build your COBOL applications inside a container, that is possible. So if you wanted to use it in your CI machines, that's fine. We also have enterprise developer versions of these images. So the very first thing you want to do when you want to deploy to Docker is construct something called a Docker file. A Docker file is essentially a series of instructions to Docker on how to construct an image for your application. This is the Docker file for my simple Hello World application. Right at the top, we have a simple from statement. This simply says that I want this image to be based off the Micro Focus COBOL server image. This contains the COBOL runtime environment, and it targets 32-bit applications. Next, you have a copy statement. This is where you copy your application from your local machine into the Docker image itself. In this case, I'm copying my Hello World application into a location inside the Docker image under C/app. Next, I am simply setting the default working directory to C/app within my image. And finally, I set the default entry point. The default entry point is what gets run when you start up a Docker container from a Docker image. So when I start my container, it will execute my Hello World application. Once you have your Docker file defined, you need to ensure that your application has been built. So I will quickly do this here. As you can see, I now have a bin file with my application in. the next step to deploying to Docker is actually building the image itself. To build an image, you simply do docker build. You can pass -t to give your image a name. In this case, I will simply call it mfdemo, CS native hello. And the final argument is the location of your Docker file. The Docker file is in my current directory, so I simply pass through dot. This then tells Docker to build up my image, and you can see that it is running through all the steps we've defined. If I enter Docker images, you can see that there is a new image in my list of images that contains my Hello World application. At this point, you have an image. To actually create a running container or a running instance of your application, you do docker run, and then the name of your image, in this case, mf demo cs native hello. You can also use the image ID if you prefer. At this point, Docker will look at your image and then create a container from it. When it creates the container, this includes your application and its dependencies and the runtime environment. When the container has been created, it looks for the default entry point that you have specified. In this case, it is my Hello World application. So in the moment, you should see that it should print some statements to screen, because that's what my application does. Once the application has finished executing, or the process has ended, the Docker container will then exit gracefully. As you can see, the container has printed some messages to screen, and the container has now exited. So at this point, we've managed to deploy a very simple COBOL application into a Docker image and run an instance of it as a container. You are probably wondering how you then go about debugging it. So to demo this, I'll quickly jump to my other desktop. If you look in my terminal window, you can see that I have already created a debug image. I will quickly run my debug image. This debug image I've created contains the same COBOL application that I demonstrated a second ago. The difference is that instead of starting my application, I've told it to start up the COBOL remote debug daemon. The reason I've done this is because when you want to debug COBOL that's running inside a container, it is fundamentally no different from doing normal remote debugging. The only real difference is that instead of a physical machine at the remote end, you are now instead connecting to a container. As you can see, when I've run the docker run command, I've specified a port number. This maps the internal port inside the container to my host machine so that my local machine can access it. As you can see, the COBOL remote daemon is now printing a message on screen saying that it is waiting on a connection to it. At this point, you want to open up your IDE that contains your application. Ensure you have a breakpoint set. Go into your project properties. Under the Debug tab, you then enter the remote debug details. Here, you specify the executable that you want the daemon to run on the remote end or inside the container. The path you specify here is relative to the path inside the container, so I simply have it invoke my Hello World application. You need to ensure that you have use remote machine checked, and here you specify the machine name or the IP address. For this, I will simply copy over the host name. You ensure that the port number has been set correctly. At this point, you can simply press F5 or start debugging. The IDE will then connect to the remote end, or the container in this case, and start up the application you specified. So it has started up my Hello World application and started debugging it. At this point, we are now debugging COBOL that is running inside a Docker container. You have your usual tooltips, your autos windows, your stack trace, You can step through your code. So to summarize, to deploy to Docker, you need to define a Docker file, which you use to create a Docker image. You can think of an image as a template, and then you create containers which are running instances of your application. To debug, you simply make use of our remote debug features. Thank you, and now I would like to bring it back to Scott.
Okay, thanks very much. Super job, Jen. Thanks for that. And apologies if you got some background noise from me during your presentation and managed to get around through that without being too distracted by me as I change my headsets. So a simple demonstration designed to be simple, really, just to give you a sense of what's actually involved. Obviously, you're dealing with things much more complex than hello world. But we'll be going into more detail and releasing more videos on this topic in future. So please stay tuned to find out about those. The best thing you can do actually is connect with us on social media, and we'll let you know when those videos are available. But just before we kind of close out on this particular section, I just wanted to kind of bring this back to the business challenge, really, that has led to the acceleration of containers in the industry today. Because we've looked at the technical challenge that is in front of us. We've looked at the technical solution that Docker and containers provide around that, and we've looked at that in the context of COBOL being applied using those technologies. But let's just understand what's got us here in the first place. And I think if we look at how software development methodologies have matured over the last couple of decades, and we see the rise and advent of agile development practices, we see the way that software development teams now approach testing of their own application and how that's all shifted left. We look at the rise of DevOps more recently. All of these things are really designed, and all of these practices are designed really to deliver on one objective, which is to really take the value that has been created by your developer, that could be you or someone in your team, and get that out into the hands of your customer, your end user, as rapidly as possible. But the problem that we face today, despite all of these new approaches to developing software and the diligence that we go through to ensuring the quality is there, we can never really guarantee with any certainty that when we deliver software that actually it will really work as we tested it and as we expect it to, because of the kind of things that we've outlined today. And when that happens, we are doing anything but delivering value to our end users. In fact, it's entirely the opposite, and really detracting and undermining all the good efforts that you've made to get to that point. And it's for that reason that when we look at the adoption of containers and Docker in the industry, we see just such a tremendous pace and rate of adoption. It's really highly accelerated, largely because teams, particularly DevOps teams, appreciate how using containers can remove another point of failure in their application delivery, removing that and allowing them with much greater certainty to deliver value faster to their customers and return that back into the business. So looking forward to hearing your feedback on this. Our customers, some of our customers are already in production using containers and enjoying the benefits. So looking forward to your feedback and seeing how this can apply to what you do. Hopefully we'll get some more questions on that later on in this webinar. But for now, let's move on to another topic entirely and pause here on containers. And this is getting on to perhaps a bit of a bonus topic here that we wanted to bring to you in this webinar today, and try as I might to come up with some clever way of putting this and to clever description. I always kept coming back to something that looks a bit like this, and it's really about new tools for finding bugs in your COBOL applications. But I can assure you these are highly innovative and unique approach to doing something that you spend 50% of your time doing as a software developer. Now, in my experience and my background as a developer, I spent many hours, many evenings, many a long evening, in fact, trying to get to the bottom of a bug of some kind. And usually the scenario for me would be debugging an application and getting to a certain path in the code base, realizing I needed to be debugging somewhere else, so stopping the session, restarting, and repeating that cycle over and over and over again, because I wasn't particularly good at doing this, but I would find myself spending hours, days, sometimes longer, trying to find the source of that bug. And if we're honest, many of us find ourselves in that kind of situation too, from time to time. This technology promises really to turn that whole process upside down and really shorten the time it takes to find bugs in your code. And it is technology that we actually introduced in the Visual COBOL 3.0 release as a preview, now available prime time in Visual COBOL 4.0. There are two main capabilities that we have available here, many different use cases that spurn off that, but let's just make sure we've got these capabilities clear in our mind. So first and foremost, as a COBOL developer with applications running on a Linux platform and using our Eclipse debugger, you can not only step forward through code line by line by line, as we're all familiar with doing, but you can now also step backwards line by line, back through the execution of the code. And from each line of code that you execute, you can see the values that were in the fields of your working storage section at the time that line of code was executed. So you can go right back to the beginning of the program and see how you got to where you did in the point of execution. And so when I described as sort of turning things on its head, what I meant by that is rather than going through those multiple debugging sessions, and bearing in mind sometimes bugs are hard to reproduce, they can be intermittent and don't always occur. Let's just run the application until it fails one time. When we get that failure, then we can just step back through the code and figure out how on earth that happened in the first place. You know, not only are we left with the smoking gun on the floor, but we can actually see who pulled the trigger because we can go back in time to see what occurred. Now, for many people, when we describe this situation, where their imagination really starts to take hold is when we talk about this actually running outside of the Eclipse IDE, which is the second key capability here. Because what you can also do here is record a live running application outside of Eclipse, record the failure, whether that's a crash or whether it's some kind of logic error, just the wrong result, not expected, and take that recording, give that to a developer who can then replay that inside of Eclipse, getting to see the cause of the problem first time. And that is incredibly powerful. When we have that kind of capability, it starts to open up all sorts of possibilities for getting to the bottom of some very hard to reproduce issues. So we're going to hand over to Blair in just a moment, but I want you to have an important concept in mind as he's going through this. The analogy here with this technology is it's like watching CCTV footage of your COBOL application. Okay, you can go back in time and you can see what happened, but you can't change history. You can see what led you to the course of events that occurred afterwards, but you can't actually adjust those variables in the past, the field, the values, but you can see what they were. And that allows you to get to the point of understanding the cause of the failure that you're seeing. So this will all make a lot more sense, I think, if we ask Blair to take the stage at this point and give you a quick demonstration to show you what's actually involved. So Blair, if you're ready, let me know when you'd like to be made presenter and share your desktop. But if you'd like to introduce yourself, please go ahead.
Thank you, Scott. I am ready. Hi, all. My name is Blair McDonald. I'm a senior product support representative in the customer support group at Micro Focus. I've been using Micro Focus products for about 30 years, a little over that, and I joined the company about 5 years ago. All right. Let's see here. There we go. All right. Let's take a look first at the reverse debugging feature. I'm using Visual COBOL for Eclipse 4.0 on Windows, but I'm connected remotely to Visual COBOL Development Hub running on a Linux machine, and you can see that here. So to do reverse debugging, what I need to do is I start debugging in pretty much the conventional way. I'll go to my debug configuration that's set up for this application. But what I have to do to enable the reverse debugging feature is under debug options, I have to check the box to enable reverse debug. Once I do that, I can start the debugger. I'm positioned to the beginning of the program. And notice that in the transport buttons on the toolbar, in addition to the conventional transport buttons, step into, step over, and so forth, I now also have additional reverse transport buttons, reverse step into, reverse step over, reverse return, and reverse resume. All right. The first thing that this program does is it performs a paragraph user prompts, which prompts the user for some basic information. And I've got a breakpoint set at the bottom of that paragraph. I'm going to go ahead and click the resume button on the toolbar to run full speed until I reach that point. Since it's prompting me for information, I need to bring up the window where I'm being prompted. There we go. All right. And I'll enter, whoops, not quite like that. I'll enter my name, and I'll enter the system that I'm working on, dev, since I'm a developer testing code here. And I'll press enter, and then I hit the breakpoint at the bottom of that user prompts paragraph. All right. Now, if you'll notice it at the end of that paragraph, just before the breakpoint, the last things that happen are a couple of move statements, which move the values that I've entered, the name and system name, into some other variables. And I can hover over those variables and see the values that were moved into them. I can see that dev was moved into identity location and Blair was moved into identity name. So now reverse debugging, stepping backwards through the code, is basically undoing what was done in the prior statement. So when I do a reverse step into at this point, I will be undoing this move statement. So now if I come up and I do a reverse step into, I'll step back once, and now if I hover over identity location, it has reverted to its prior value of spaces. So that's the effect. I get to see not just the current value of a variable, but as I step backwards, the prior values. And I'll step backwards one more time, and now identity name has reverted to its prior value of spaces as well. Now, when I'm using the reverse debugging feature, breakpoints take effect whether I'm going forwards or backwards. So if I set a breakpoint back at the beginning of this paragraph, and then I do a reverse resume, I'll zoom back to the beginning of the paragraph. And at this point in the execution, the prompts have not happened yet. So the username and identity name fields that were accepted are currently empty. Only when I step forward through the recorded portion of this session, I'll step past the display. And when I step on the accept, this time I won't actually get prompted because it's working from the recorded information, but the username field will again be filled in with the value Blair that I entered. So that's a quick example of using the reverse debugging feature. I'll stop the debugger, and I'm going to turn off my breakpoints. And now let's take a look at the other feature I wanted to talk about, live recording. Let's imagine that this application now has been deployed to a QA environment for testing. And one of the QA test engineers has tried it out and discovered a problem and reported it back to development. That engineer can be instructed to turn on the live recording feature so that when they run the test, it actually records the entire execution of the program. So now here in the deployed directory, if I look, I see my program, and I'm going to execute that. So it's the same program, but now I am end user, and the QA person enters the system name they're on, which happens to be QA. So basically, we're at the same point we were before, But when they continue on with the program, whoops, we got a runtime error, a subscript out of range error that happened later in the execution. All right. Now, since they've turned on the feature for live recording, when I look again, there's actually a recording file that's been created of the session. So that recording file can then be provided back to development so the developer can run through the program and see everything that happened during the execution. So I'll go back to the debugger now, and I'll switch and use a different debug configuration. There's a new debug configuration type that was added called COBOL Live Recording. And when I switch to that debug configuration, I'll specify where the recording file was that was provided to me by the QA person who encountered this issue. So I've specified a recording file location. I'll start the debugger. It asks me to choose which recording file in that location. And now I'm positioned to the beginning of the program. Now, again, since I'm watching a recording, I can step through and see what happened if I step forward into the user prompts paragraph and across the accept statement. I can see what the user entered. So I'm able to see all the values that were entered by the user during execution. All right. But maybe what's most useful at this point, since they've reported a particular problem with executing the program, that they received an error, is just to resume forward. And I hit the point of actually the error being generated during the replay of execution. So I get the same error that the user saw in their testing of the application. And when I click OK, I'm positioned to the line in the code where the error actually occurred. So this move statement is what caused the error, and the error was a subscript out of range. So hovering over the subscript, I can see that it contains a 0. Well, here's the reason for my error. The 0 is not a valid subscript value. What I'm able to do in the live recording session is actually set a watch point on this variable and then reverse debug, go backwards through the execution to find out how did num1 come to have 0 in it. So to do that, what I'll do is I'll go to the definition of that variable. I'll set a watch point on the variable. Once again, that will cause execution to stop whenever that variable changes. I'll return to the point in the program where the error occurred. And then I'm going to do a reverse resume to go backwards through the execution. And when I do that, I find that the variable value changed on this subtract statement. In the variables view here, I can see that the num1 variable currently contains 3. That's still a valid subscript value. But when I step forward now through that statement, now num1 contains 0. So this is the statement that caused the error. So it's very useful to be able to isolate not just what was the bad value, but where did it go wrong and how did it come about. I think that completes the demo. Scott, I'll go back to you now.
Terrific. Thanks very much, Blair. Thanks for that faultless demo. Let me just make myself presenter here, and we'll get back to the slideshow. So if any of you actually watching that and have got experience of using a core file to debug, you'll know the limitations of the core file. You see the application at the point of failure, analogous to that smoking gun, but you can't really see who pulled the trigger. You can't really examine how you got to that point. And I think you in particular will appreciate the power of what you've just seen there and what you could start to do to resolve application failures. So thank you, Blair. Ed, I think it's time to bring you back onto stage to close out the session.
Scott, thank you very much. And Blair and Jen, thank you as well. Great demonstrations of some of the latest features in Visual COBOL 4.0. Yes, let's wrap things up here with a quick look at some of the resources that are available for you. There are many resources that are available today, and certainly, as Scott has indicated, there'll be some others coming very soon. But I think of most interest to you to start would be the documentation. How do we get access to some of the data sheets and new material, a snapshot of the new features that are available in 4.0. All of this is available for you and with updated material on the Visual COBOL website, microfocus.com/Visual COBOL, or simply visualcobol.com. Also updated on those pages are a new set of product trials. So we have a new commercial trial that's available for you where you can test all of the capabilities that you've seen here today, including the Docker capability, and reversible debugging, and live recorder as well. So simply jump up to our website and register for a free copy to get started, a free trial. We also have an updated trial for our personal edition of Visual COBOL. And again, this is a slightly different product. It's designed specifically for our student developer or those perhaps learning or desiring to learn and advance their skill sets around the modern syntax and modern language, being Visual COBOL. So it's certainly not the commercial version, but it is updated. I certainly encourage you to take a look at that or share that with folks that are learning to or desiring to learn the language and become more adept at that skill. And certainly, as Scott had mentioned during his session, there's new documentation, product documentation that goes into all of the features that you've seen here today and many that you haven't in a lot more detail. So we encourage you to take a look at our documentation site to get all of the information you're looking for around this latest release. Please continue to watch your inbox as well and social media, the community channels for new material that we'll be releasing very soon. A new set of product videos that goes a bit deeper into some of the material that you've seen here today. And of course, today's broadcast, today's webinar is recorded and will be posted on the Visual COBOL website very soon. So lots to take advantage of right away, lots to look forward to in the coming weeks. What we'd like to do now, though, is hear from you. You've had an opportunity to see some of the capabilities in action. You've got an opportunity to hear from both Scott and I, but I'm sure you have some questions. So for that, I'm going to turn things back over to our moderator, Brandon, to help facilitate the Q&A panel. Thank you.
Thanks, Ed. We've got a few questions here in the queue we can go ahead and jump into. One of the first here that had come in asks, with regards to Docker, does it require .exe for the application, or can the container hold .gnts files for the application?
Hello?
Hey, Jen, go ahead.
Yes, you can use gent files or int files. That is absolutely fine.
All right, nice and easy. This question asks, what's the earliest Visual COBOL release with watch point support of any kind on Windows Eclipse?
Oh, I'm not sure. It is. I'm not sure offhand. It's certainly been in for a few releases, shall we say? So certainly 3.0 and some releases before that. I couldn't say for sure. But perhaps if you're thinking about upgrading, I know there was another question in the queue there, a pre-submitted question about upgrading from earlier versions to Visual COBOL to the latest one, and how you had to go through, whether you needed to install previous versions first of all before getting to 4. For example, if you're on 2, do you need to install 3 and then 4? So Blair, actually, if you wouldn't mind jumping in to answer that, what's the correct installation procedure when upgrading? Do you need to worry about installing interim releases?
No, you do not need to worry about installing interim releases. You can go straight to the new release and install it and upgrade.
Excellent, thank you. So if you haven't got watch point availability, install 4.0 or 3.0 and you should be up and running.
Great. All right, Scott, here's a few more coming in for the team. This one asked if the app code is failing because of a data or setup in the environment, and when we record it and play it elsewhere, where would we debug the code? Where the same setup data is not present, then would be able to play to generate the same error message which we got on the first environment? don't know if I totally butchered that one for you or not.
I think Blair and I could probably make an attempt to try and get to this. I think we understand that the issue is you've recorded a failure, but there was infrastructure and data and other things that were needed to at the time the failure occurred. Do you need all of that when you replay it? Then the answer is generally no, you don't. The recording file has everything that occurred, and the data that was transmitted and used in the program is contained within that. So you should be able to take that recording and run it on the developer's machine. Blair, is that satisfactory? Would you add more to that?
Exactly right. In the demonstration that I did, I showed that when I played back a recording and went through an accept statement, it already had the data from the accept statement. And in the same way, it has the data from everything else that has happened during the execution, including I/O from files or databases. So you can pretty much just play the recording and have all the data provided during the execution.
Great. All right, here's another Docker question that's come in, saying it's really nice to see built-in Docker images with the development tools and the runtime that are provided, but asked, how do you validate the license onto those images?
Oh, good question. So actually that's one of the areas that we endeavor to simplify when you come to use Docker, to try and make it just easy to get not only the software installed, but the license installed as well. So actually you'll find it's a greatly simplified process. When you create the Docker image that Jen went through earlier on, he kind of already had the image created. It takes, can take a couple of minutes to pull all that stuff together. So we didn't go through the whole laborious process there. But during the construction of that, you can register the license key as part of the creation of that image, and then that container has the key ready to go, and you can run that image in a container, and it's already licensed. Okay, any more questions about licensing and any commercials around that, please get in touch with your account manager, and they can arrange more demonstrations around Docker and go through those details around licensing with you over a call.
Great. Thanks, Scott. We had a couple questions here asking about the reversible debugging and live recording, and when that might be available in Visual Studio.
Blair, do you want to take that one? I'm joking. I have to take that one. So actually the technology that we showed you today, it's strictly available for Intel Linux platforms only. Okay, and one of the reasons why we decided to embed the technology, even though it was limited to Linux, is just because of the adoption rate of the Linux platform amongst our customer base. And Linux is by far and away the fastest growing platform that we have for Visual COBOL today. Windows and Linux together represent the overwhelming majority of customers today. Although we have customers deployed to all platforms, it's clear that those ones are getting a lot of attention. But the technology is really restricted to the Intel platform, and by virtue of that, we've made the debugging experience available through Eclipse only today.
Great, thank you, Scott. Here a bit of maybe a series of questions. I might just throw all these out, and maybe you can get them all in one go. So the images created, or it's asking, are the images created platform independent? Can they deal with cross-platform and complex platform product applications? And also asking, is the Visual COBOL data division size limitation increased? And as well, do we need any extra hardware to use these Docker containers? Let me just hit you with a nice barrage there.
Yeah, there's a few questions in there. Some of them are different. As the data division size being increased, I think that's probably entirely separate to the Docker questions. That's something I don't think I can answer on today's webinar. Blair may offhand know the answer to that, but if not, that's definitely a question to ask our customer care team. They can tell you, depending on the product that you're using today, they can tell you what the data division limitations are and whether we've increased those in Visual COBOL. I'm sure you've already had some of those conversations, but please, go through those again and bring them to my attention if you want my opinion on that, my perspective. In terms of portability of the Linux containers, actually, yes, there is portability there, although our images that we base our software on, the images on, sort of inherit from either SUSE Linux, Enterprise Linux, or Red Hat Enterprise Linux containers. And in those situations, typically what people will be doing is running them on Red Hat or SUSE distributions. If you want to deploy other variations of Linux, then you can do so. You can create your own Docker files and then import from, if you remember the Docker terminology, from other OSs, and incorporate your applications to that, your own well-defined image, and that can give you increased portability. We're not yet at the point that we can run a Linux distribution on Windows platforms, but keep watching this space. Perhaps we will have some news for that for you in the future.
That sounds good. Well, here's a few more here in the queue. We can hopefully try to squeeze in here in our time frame. Again, some questions about Docker. It asks, does the Docker support also work in Eclipse and COBOL for JVM?
How about that, Jen? Working okay in Eclipse and JVM too?
Yes, it does work in Eclipse and JVM. It supports native code, JVM code, .NET. It runs across the board for the most part. Yeah.
All right.
Thank you.
I've got another one here, Brandon. A submitted question around Docker, so this might be for Jen as well. It refers to best practices for debugging in Docker. Do we have any suggestions there?
In my experience, when debugging in Docker, one of the simpler things to do is to volume mount your local development directory inside the Docker container itself. This avoids the need to constantly rebuild your image. It means that any changes you make whilst developing, you can build immediately inside the IDE, and the changes are reflected directly in the container. This makes your turnaround time for actually testing your code very quick when developing. So that would be my recommendation.
Thank you, Jen. Yeah, there's various approaches, isn't there? But that's a particularly useful one, as you say. You don't need to keep recreating that image if your application changes. Hopefully that's helpful to the person who asked that.
Great. Scott, we've got another one probably coming your way. Asked, is Docker really only useful for deployment, or can I use that in other ways?
Right, yes. That's a good question, yeah, because we did really focus on deploying your application, and I think that's probably where the highest value comes from. But it's not the only way you can get value from using containers. And another obvious place, in fact, Jen mentioned this in his session, is even if you're not deploying the container to your customer, maybe you've got a continuous integration system, you're building your applications on a CI machine, and you're going through a testing process. Inserting Docker into that model can give you some great benefits in terms of getting a CI system set up very quickly, about keeping everything that you build isolated from the rest of the machine, so you are really testing what you've just built and you're not sort of polluting the environment that you're working with in. So certainly CI is a very good first step for using containers. There are other ways as well. We'll sort of highlight those as we kind of release a video going into more detail on Docker, hopefully in the not too distant future. CI is a good first step before you think about production.
Thanks, Scott. We had a couple here related to the undo functionality. So these, Blair, looks like a few you can help us out with. This first one asks, can I use undo on AIX?
No, undo is only available on Linux x84 platforms.
Okay. And another use question, can I use it with the SOA functionality?
Yes, you can use it with the SOA functionality. There's a feature to be able to, under Enterprise Server, enable the reverse debugging and recording features so that you can make use of the functionality when running a service.
Great, thank you, Blair. Had additional one here. mentioning the reverse debugging and the performance. What are the implications? How is that performance when it comes to reverse debugging?
Oh, I'll give it. Oh, go ahead.
Go ahead.
Well, okay.
My impression is that with reverse debugging, since you're interactively debugging, there is some impact, and I get the impression it's something on the order of maybe things take roughly twice as long as they would outside of reverse debugging or live recording. Is that consistent with what you've heard, Scott?
Yes, it is. I mean, there is a range. That's not a bad range to give, Blair, at all. I think what I would say is that this technology that we embed in Visual COBOL, this undo capability that we've mentioned, is actually provided by a company based here in Cambridge in the UK, who've patented this technology mainly because of what they're able to achieve in terms of performance, limiting the performance overhead of the recording itself. And there are actually other alternatives out there on the market, but many of them just really are not feasible to be used in most scenarios because the performance is just so poor. So yes, you can certainly expect a performance overhead, and we've been working alongside this company to help minimize that as much as possible, and will continue to do so because performance is always important. But so we're certainly not recommending that you leave undo live recording technology switched on all the time throughout your application when it's in deployment. But when you do encounter those issues, those intermittent issues that do occur, and yes, you might add an overhead to the application that makes it take longer to run and complete. But if you compare that to the time you spend trying to find out the cause of the problem through other means at your disposal today, certainly that additional overhead can be more than acceptable if it gets you to the solution faster. So yes, performance overall, yes, of course it's impacted, but we work to minimize that as far as we possibly can. 2 times is not a bad range to give. It can be worse, it can be better.
All right. Thank you, Scott. We had a couple more here in the queue to hopefully get to. And again, thanks for everyone for continuing to hang on. We know we're running a little over. This one asks, does call debug break also work in Docker?
That's a good question. I'm not sure. I'm not sure what happened with the CBL debug break call. Jen, do you happen to know, would the remote remote debug attached to that? Possibly. I don't know. We might have to get back to you with an answer to that on the community website, which is the place we usually go to answer the questions that you've put to us that were too tough to answer.
Right. I mean, it's to stump our expert here, so hey, congratulations.
Yeah. No, don't call me an expert. I won't hear of it. All right.
It looks like we had one final one here in the queue, a bit related to licensing, but in my somewhat layman's terms, I think maybe a bit of a different twist than what had been asked before. Saying he's guessing that the Docker container contains a runtime. So this is regarding to that runtime licensing. How does that work with Docker? Is Docker a requirement to deliver applications we typically just where we just ship the COBOL source and have the customer compile it on site?
I probably need to study that question again in more detail, but you certainly have the choice to use Docker in that environment. There's nothing stopping you, and as Jen described, although we showed you running an application inside of a container, absolutely, you also have available to you to build your application inside of a container. And not only are the results of that build process the application that you've created, but can also be a container itself, a new image, with the application and the runtime, the Micro Focus runtime, all packaged up in a single image. And that could be what your customer then chooses to run on site. So the advantages of doing that could be everything that we've described to you today. Your end customer could attain those advantages, that the thing that they build, the application that they create, will have everything that they need pre-prepared inside of that image, ready to run in their environment. So certainly a valid use case for you to consider.
All right, great. And we actually have one more sneak in here, so let's hopefully we can get this one in as we wrap up. Kind of a question, but more confirming that they understood correctly here. So using Visual COBOL 4 with Docker, I can standardize units for development, shipment, and deployment. I guess make sure, did they understand that correctly? Is that a true statement?
I'm just trying to see the question here because I'm not entirely sure what was meant by that. Standardizing, I think standardizing is as good a term as any about what we're talking about here, standardizing what you ship. But I suppose, just to reiterate remarks we've already made, you're providing a well-known application image with all of its dependencies present in that image, which you can then give to your customer to run on their machine reliably, because you know that the application has everything that it requires to run, and you're not at the mercy of an unknown environment not having everything that you need there, that is otherwise out of your control.
All right. Well, thank you, Scott. Well, it looks like that has gone through our questions. So I was going to pass this over to you, Ed, if you have any closing comments.
Brandon, thank you very much. Scott, Blair, Jen, thank you as well. Great conversation there. Lots of great questions. And as you said, Scott, I think we'll need to get back to the community here by responding to some of these questions, some of the tough ones, and posting them on our community forums. So we'll certainly look to do that following today's event. Just in terms of some next steps, as you look beyond this webcast, as I mentioned, there are new updated product trials that are available for you. So if you like what you see here, if you would like to dive a bit deeper into the content and try it for yourself, you can download your free trial, your free starter for Visual COBOL at the website below, and quickly get started in using Docker. And of course, Micro Focus, our support team, are here to help you throughout that trial process. If you do have additional questions, particularly related to licensing, or how would this be applicable for you, or trying to map out the right solution for your environment, we'd love to sit down and chat with you about your challenges and help you put the right solution together. And we certainly have a means to do that through our value profile service, a complimentary service really for our customers. So we encourage you to reach out to your account manager, or you can simply reach out to us via the link below. We'll get in touch with you with those next steps and get you started on your journey. So with that, on behalf of Scott and Blair and Jen, thank you very much for spending your day with us, a part of your day with us here to introduce Visual COBOL 4.0. Great questions. Looking forward to interacting with you more on the community. Please look for this website, this recording that will be posted on the Visual COBOL website very shortly. You can share that with your colleagues. Again, thanks very much. Have a great day.